Hi, welcome to our study of chemical reactions at the PreAP or 10th grade honors level chemistry class. We're at Allen High School. All my Allen kiddos, welcome. All right, we're on our last reaction, combustion. Now, there's really only two tricky parts to combustion, and we've introduced this already, so I'm going to jump right into the fray. Our two tricky parts of combustion are, one, you have to supply the oxygen. All right, it's just implied, or not implied, it's expected that you know that a combustion is fueled by oxygen. The products are always the same. They're always going to be, for our level, CO2 and H2O. Now, combustion's a much broader classification than we're studying, but for our level, it's going to be CO2 and water. The second tricky part, in addition to remembering to add your oxygen, is sometimes these get a little tricky in terms of balancing. So let's take a look at some of these so that we get an example of some of the balancing issues that we can run into. All right, so we have propane gas. This is a simple ane. Prop is 3, right? Meth, eats, peoples, that's 3 carbons, brains. So C3H8, it says it's a gas, lovely. We have to supply the oxygen, and that's a gas. And we're going to always be doing the complete combustion. And we're going to form H2O gas. Sometimes you'll see a liquid there, but we're going to put H2O gas, and CO2 is a gas as well. Now comes the issue of balancing. Sometimes these are pretty straightforward, and sometimes you have to kind of put in double the effort. Now, I start with my carbons and I end with my oxygens. So I have 3 carbons here. I'm going to put a 3 here. I've got 8 hydrogens there, so I'm going to put a 4 there. That gives me 8 hydrogens. Now I have 6 plus 4 oxygens, which is 10, so that means I need a 5 here. Now, redox oxidation came originally from the study of substances combining with oxygen. So this is going to be a big fat yes, always. Plus you see element with an oxidation number of 0 going into compounds. All right, so that's our other clue. But redox, at its very beginnings, the very beginnings was the reaction with oxygen. So that's definitely a redox reaction. Okay, let's go on and see some more examples and some more pitfalls if we're not careful. What we'll have, all right, we have the burning of octane. Oct is 8. Ane is double plus 2, so 16 plus 2 is 18. The problem tells us it's a liquid. You have to supply the oxygen, and we know it's a combustion because of that word balancing there. CO2 gas, don't want to get sloppy on you there, sorry, and H2O gas. And yes, it's a redox, yes, it's a redox, yes, it's a redox. These are all redox. Okay, so now we want to balance this. Start with your carbons, so I'm going to put an 8 here. Then my hydrogens, I've got 18 hydrogens, so I need a 9. So now I have a 16 and 9. That's 25 oxygens. I don't know how I'm going to get 25 out of an O2 directly. Now, I will tell you that at upper levels, you might see 25 halves O2. That's not physically reasonable, but it does technically balance the equation. We're requiring you to balance using the smallest whole number ratio. So if I want to make, I'm going to put a 1 there so you'll see what I'm doing here. If I want to make an even number, an odd number become an even number, I double it, right? That always works. So what you do is you go back and you double all of the coefficients, and I'm going to rewrite this because this is pretty messy right now. Sorry, that's an 18. And now, if you recount your oxygens, we'll find we need 25 O2s because there are 32. There's 32 plus 18. There's 50. So that's how I would get it. So let me erase and rewrite. That's what I meant by doubling your effort, so to speak. All right, so let me see if I can just delete that without deleting everything. This eraser's kind of big. And let me rewrite for you to clean it up so you have it really clear in your notes what we did here. Okay, we had C8H18, so we had to, excuse me, Dina. Okay, so I put an 8 there because that's what I was saying, rather than a 2, which is what I was thinking. So I need a 2 there, and that means I need 16 here. And I had a 25 here, and I need an 18 there. Okay, so that's balanced. So if you end up with an even-odd issue with the diatomic, go back and double your other coefficients and then recount fresh. Let me look to show you what the pitfall here is. C2H5OH. What's going to happen is when you count your oxygens, you're going to forget that oxygen. Happens all the time. It's a liquid plus O2 gas. We're still going to make CO2 plus H2O. All right, now let's balance it and watch out. Make sure you include that oxygen. Most common mistake. So I have 2 carbons and 2 carbons. I've got 5, 6 hydrogens, so I need a 3 here. So that gives me 4 plus 3. I have 7 oxygens. Well, I have 1 oxygen here. So this one only has to supply 6, and it'll do that with a 3. Okay? And I think you get the idea now, so I'm going to finish up this video and we will work some more. If you need more help, have me work this one for you in class. Until then, this is signing off.